Hello, this is Barry Stevens. I'm from Ventacity Systems, and I'm going to talk about the future of healthy, efficient buildings today. Specifically, I'm going to talk about very high efficiency HVAC systems and with the Ventacity HRVs and ERVs applied to building systems. We've done many projects across the country. This is an office building in Tarrytown, New York, where we replaced the rooftop equipment with very high efficiency, Passive House certified ERVs. Those are the blue boxes you see in the middle picture there, and VRF heat pumps with heat recovery. We have here the three graphs shown here. The top one is what we found with heating in red, cooling in blue, plugs and lights in gray. There's a small line of green across for fan power. The second graph is if we had just replaced the existing SWIP systems with code compliant systems. And the last graph is the design with VRF heat pumps and very high efficiency ERVs. We exceeded the model on this. We looked at a 71,000 square foot office building and replaced the existing systems. And as you can see, the peak demand went from 519 kilowatt hours in June down to 366 kilowatt hours in November. So a very significant peak reduction. The summer peak, which was formerly the highest amount of use, was down at 208 kilowatt hours in June or July. So very significant savings. We exceeded the model here, you can see, by about 300%. The total energy savings for HVAC on this building was in excess of 70%. How do we do this? Very, very high efficiency heat recovery, energy recovery ventilators, which provide the outside air into the building with an extremely small energy load. And we do this with units that provide a COP, or coefficient of performance, shown here as up to 20 in the summertime and as high as 30 or better in the wintertime. We looked at a project outside of Seattle here, where we were looking at conventional efficiency of about 70% ERVs versus the Ventacity very high efficiency at 85% efficiency. Fan power was reduced by half, and the COP went from 5 to 10 for the ERVs. And as a result of that, we were able to save over six units on that school. And over a 10-year period, we're modeling it at almost $140,000 in energy savings. So very easy to justify the increased cost between a conventional 70% efficient unit and 85%. That 15% difference is 100% difference in energy or better. This is a project we looked at in New York City using those same metrics, 70% versus 85% on the ERVs versus what's there now, which is 0%, bringing raw outside air and directly into the building, heating it or cooling it with gas or electric, and then distributing the air into the spaces. Again, you can see that system COP ventilation was twice the COP, or coefficient of performance, for the better ERVs, and the total system COP went from the existing 0.75 now up to 5.3. So we're looking at about an 80% energy savings on that project. That project is shown on the left. We've done a whole range of these projects. That's a 50-story office building in New York City. We've got a historic building in Chicago. We've got a temple and school in Chicago. We've got a 500,000 square foot mall in White Plains, New York that we're looking at. So we've got a whole range of projects and applications that you can use this method. The key is the Passive House certified very high efficiency HRVs and ERVs, using a counterflow heat exchanger, aluminum plates in the HRV, which just transfers heat, membranes that transfer heat and moisture in the ERVs, but all in the counterflow orientation. Whole range of products that can go on the roof, in the building, in the classroom specifically, so we can meet pretty much any application on commercial buildings. Thank you very much.